Hi, welcome to my second video. We're both here because a regular review gets a better grade for you. Today's video is all about building confidence with the mathematical applications of physics. It's my top 10 tips for maths in physics. I haven't forgotten the answer to the challenge in video 1. Here it is. The wave was moving from deep water to shallow water, so it got slower. The wavefront was coming in at an angle to the boundary, so the right side of it has hit that boundary first, and this has caused the wavefront to bend towards the normal and slowed it down. The peaks have also got closer together. Now that's because the frequency was fixed, so as the speed decreased, the wavelength had to decrease too. If you got it right, how's that feel? You feeling proud? Why not leave us a comment and let us know? And so on with today's topic. Top 10 tips for maths in physics.
Tip 1.
Highlight the relevant bits of the question. Some are really wordy and you need to unpick what you're being asked to do and what you're being told. Sometimes I find drawing a picture can help me look at the problem too.
Tip 2.
Decide which equation or equations you need to use. For this video, I'm focusing on just two equations, the ones that are linked with the speed of a wave. For the new 9-to-1 GCSE, you need to learn these as well as apply them. If you need to rearrange the equation, though triangles are really helpful tools, let's have a look at how to make one. So here, I can make a triangle. I have to have the frequency and the wavelength in the bottom of my triangle and my velocity, the speed of a wave, at the top. To make this triangle, when I cover over the speed, I need to have distance divided by time in my triangle, so distance has to go at the top, which means my triangle looks like this. Now, if I need to know the wavelength, I can cover over wavelength, and it's telling me to do the speed divided by the frequency. If I need to know the distance, I could use this equation and it would be speed times time. Triangles and how to use them.
Tip 3.
This is all about substituting in the numbers in their standard units. So you might want to hit your pause button because you could test yourself here by having a think before revealing each answer. Let's go, Tom. So, wavelength. What's the unit for wavelength? Reveal. It's metres. Distance. Distance is measured in, pause, try, and reveal. It's metres again. Time. Time is measured in, reveal. Oh. Seconds. Speed. Look at my speedy speed. Speed is measured in, don't forget pause, metres per second. And our final one is frequency. Frequency is measured in hertz. Don't forget some of the trickier ones. Nanometers. That is 1 × 10⁻⁹ metres. A kilometre, of course, 1,000 metres is a kilometre. And don't forget the time in seconds. So 1 minute is 60 seconds.
Tip 4.
Show every step in your working out clearly. So if you tap it in your calculator, you write it on the exam.
Tip number 5.
Check your answer makes sense. For example, if they're getting you to work out the speed of light, you're expecting 300 million metres per second. So if you get like 3 × 10⁻21 as your answer, or 3, then you should realise you're wrong and go back, check what you did.
Tip number 6.
Finish off your answer with the correct unit. If you need to, rewind, go back to tip 3 and practice those units again.
Tip 7.
Know what formula you need to learn. One way you can do this is building your own formula sheet. When I had exams, I used to practice writing out the formula that I wasn't going to be given, and I'd make like a personalised formula sheet. Then in the exam, I'd start by recreating my practised formula sheet so that when I got to a maths question, I didn't have that mind blank panic moment. I practised and practised creating that sheet so that I had everything I needed to do the problem quickly, and the time it took me at the start of the exam to draw it out was easily saved in the rest of the exam when I had it to use. Be aware of what you'll get in the exam and what formula you need to learn.
Tip number 8.
Use the marks available as a clue, but 1 marks are rare, pretty much as rare as a porygon. 2 mark questions might not need a rearrangement, might not have odd units, but beware. Sometimes you seem to have to do quite a lot of work for 2 marks. 3 marks, they're going to have a rearrangement in them, and there's probably not going to be standard units there. For 4 marks, you need to be prepared to use more than one equation here. There's definitely going to be a rearrangement, and your units will get tested too.
Tip number 9.
Know how to use your calculator. Practice with your calculator. Do it with the one you're going to take into the exam. Don't reach for your phone just because it's nearer. Get to know your calculator really well.
Tip number 10.
Don't panic. Stressed people misread questions. And don't give up. Never, ever leave a question blank, because you can always pull marks out by having a go. Practice makes perfect. Why not ask for my special booklet? Because it's a great feeling when you solve a complex calculation. And with practice, you can love the maths in physics too. So, to finish, I think it's a really good idea if we just show you some of these tips in action. So here's our question. Blue light has a wavelength of 470 nanometres. Well, let's get that highlighted because that's important. And a frequency of 6.3 times 10 to the 14 hertz. That's important. We're having to calculate the velocity of the blue light. So, highlighted. I'm going to have to decide what equation to use here. I've got speed is what I need, so I'm going to do frequency times wavelength equation. When I substitute my numbers in, I've got to watch frequency's okay at 6.3 times 10 to the 14, but that's nanometres, so that's 470 times 10 to the minus 9 nanometres. Reaching for my calculator, I'm going to pop those numbers in, 4.3 to the power of 14, times by 470 to the power of 9 minus. Now that's quite a big number. Does that number make sense to me? Speed of light, 2. Yeah, of course it does. Because if I round that up, that's 3. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 10 to the 8. Of course that makes sense. Speed of light. I reckon I got that one. And I got both marks. Let's try another. So we've got an earthquake causing seismic waves. S waves being one type of seismic wave. A lot of waffle here. They travel at 0.65 kilometres per second. That might be important in a minute. There is a seismometer 80 kilometres away. Now everything's in kilometres, so I'm not going to bother changing that to metres in a minute. It shows us that it takes about 2 minutes for the waves to travel. Everything's kilometres per second, so I'm going to have to think about that. And they're asking us to just prove that time. So this is going to be a speed is distance divided by time question. I know the speed and I know the distance, so working out the time is going to involve me doing distance over speed. That's going to be a distance of 80 kilometres over 0.65 kilometres per second. That's going to get me my time in seconds. So the calculator comes in and I'm going to do 80 divided by 0.65. That gives me 123 seconds. Obviously, if I divide that by 60, I can get it into minutes. And so that gives me 2.05, which is basically 2 minutes. I've proved it. And I'll have got 2 marks doing so. Our penultimate example. We are told both infrasound waves and ultrasound waves are types of sound waves. They're used by animals to communicate. Hadn't highlighted a thing yet. 2 elephants use infrasound waves for long distance communication, and the distance between these elephants is the 2,500 metres. Elephant A emits a sound. That was my elephant sound. This sound is going to then travel to elephant B. Boing. The elephant hears the sound and it calls back. That was not great elephant sound, but it was an elephant sound. And the speed of the sound, we're told, is 340 metres per second. I've got to show that the minimum time for elephant A to hear the call and answer from elephant B is 15 seconds. So this is a there and back.
Is it distance by speed?
Oh, not far off.
Oh.
Speed is distance over time.
Yeah.
It's time I want. So that will be distance, speed, time. Distance divided by speed. Is that what you just said? Hey, yeah. My son's a genius. Distance in this case is 2,500 metres. And the speed in this case is 340 metres. But remember, the sound's got to go there and back. So this time is the time there and back. So 2,500 divided by 340 gives me 7.35. So that's only the sound travelling in one direction. For it to come back as well, I'm going to have to double that. So it's 7.35 doubled, which gets me to 14.7, which is pretty much 15 seconds, because that's what we had to prove. I reckon we've got all 3 marks there, young. So this is the last example. The distance between the Earth and the Sun we are given at 1.5 times 10 to the 11 metres.
Distance.
It's a jolly long way away, isn't it? A light takes 500 seconds to travel from the Sun to Earth.
Time.
So we've got a distance and a time. I reckon they're going to get us to work out the speed, don't you?
Yeah.
Oh, now we've got the wavelength of the red light is 670 nanometres. We'll get to them in a minute.
Distance.
No, wavelength. Well, wavelength is a distance. It's
Exactly.
a distance from peak to peak of a wave. Calculate the frequency of the red light. Right, so this, you know what, we've got to do 2 equations here.
So does this mean it's a 4 marker?
I don't know. Yes, it is. Look. Use the marks to guide you. That's how we know this is a 2 equation question. Right, so first of all, we need to work out the speed from distance divided by time. The distance is 1.5 times 10 to the 11 divided by the 500 seconds of time. That's where the calculator comes in. Hello, friendly calculator. Will you do my answer for me? Divide by 500 gives us... Oh, look! It's the speed of light. Fancy that. 3 times 10 to the 8 metres per second. Right, frequency. Speed equals frequency times wavelength. We want the frequency, so we need to go speed divided by wavelength. The speed in this case is our 3 times 10 to the 8. Our wavelength, and we've got to watch that nanometres here. You can see why it's worth the 4 marks, can't you, Tom?
Yeah.
So it's 670 times 10 to the minus 9 for nanometres. Let's divide our answer then by 670 to the power of 9 minus and see the frequency. It is I'm going to round this to 4.5 times 10 to the 14 hertz. Ow! 4.5 times 10 to the 14. There's our 4 marks. And I feel good. So, go highlight. Decide on your equations, rearrange them, standardise your units, show your working and your final units with confidence. Get set to answer those questions with answers that make sense because you learnt your formula, you didn't panic and you used the marks as a clue, using your calculator without hesitation. And remember, regular review gets a better grade for you. A massive thank you to Tom, who helped me make this video because I couldn't have done it on my own. And remember, if you want other top tips on revision or exam techniques, you know how to comment. So like, comment and subscribe.